2018, the world watched as a new robotic explorer touched down on the dusty plains of Mars. NASA's InSight mission promised to listen to the very heartbeat of the red planet. There was excitement, headlines, and a surge of curiosity, but after the first photos arrived, the public's attention seemed to fade. And yet, while Mars fell silent in the news, InSight has been working tirelessly, uncovering secrets hidden deep beneath its surface. So today, let's take a journey together. What exactly was InSight's mission? What challenges has it faced, and what discoveries has it made? By the end, we may see Mars in a very different light. InSight launched from Earth in May 2018, travelling more than 480 million kilometres before successfully landing in November of the same year. Unlike the rovers most of us are familiar with, such as Curiosity or Perseverance, InSight is a stationary lander. Its job was never to roam across valleys or hills. Instead, it was designed to sit in one place, listening patiently to the planet beneath its feet. In many ways, InSight was a spiritual successor to Phoenix, an earlier mission that landed in the Martian Arctic. But where Phoenix sought signs of habitability, InSight had a different goal: to explore the inner structure of Mars itself. For the first time in history, scientists hoped to measure Marsquakes and trace how seismic waves move through the crust mantle and core of another planet. The moment InSight touched down, it confirmed its safe arrival by sending a radio signal back to Earth, followed quickly by its very first photograph. The image was blurry and covered in dust, kicked up by the retro rockets that had slowed its descent. To protect its energy supply, InSight waited a few hours before deploying its twin solar panels, ensuring the dust settled before they unfolded. And then, even before its instruments were fully deployed, InSight began to surprise us. Its highly sensitive seismometer, still mounted on the lander, picked up vibrations caused by the Martian wind. For the first time in human history, we could hear what the wind on Mars sounded like. The vibrations were so low-pitched that most people needed headphones or subwoofers to notice them. To make them easier to perceive, scientists shifted the frequencies upward, turning the invisible breath of Mars into something we could actually hear. But sound wasn't the only clue. InSight also recorded fluctuations in air pressure, while its cameras caught delicate water ice clouds drifting across the sky, showing us that even on a barren world, the atmosphere still holds traces of motion and lifelike activity. Very soon after landing, InSight turned its attention to the main task: setting up its scientific instruments. Using 3D imaging, NASA carefully mapped the terrain around the lander, even recreating the area with augmented reality headsets back on Earth. The priority was clear: find the best possible spot for the seismometer. The device had to be placed directly on the surface, away from rocks or uneven ground, and covered with a protective shield to block wind noise. Once ready, InSight's robotic arms slowly, deliberately lowered the seismometer into position. From that moment, it became Mars's first true stethoscope, listening for the faintest tremors, from deep Marsquakes to distant meteorite impacts. Alongside the seismometer was another ambitious experiment: the heat flow and physical properties package, affectionately called the mole. This self-hammering probe was designed to burrow up to 5 meters below the surface, measuring the transfer of heat from the Martian interior. Every 10 centimeters, it would take readings, building a temperature profile that could reveal how thick the crust is and whether Mars's mantle remains geologically active. But things did not go as planned. After just 30 centimeters, the mole stalled. It seemed to lack the friction needed to dig deeper, possibly because of unexpected soil conditions or hidden rocks. For months, engineers back on Earth recreated the problem, adjusting strategies with painstaking care. They even commanded InSight to lift the mole's housing, exposing the stuck instrument, and used the robotic arm to press against the soil in hopes of giving it more resistance. Progress was painfully slow, and as of now, the mole has yet to achieve its full goal. Still, the story is far from over. While the mole struggled, the seismometer thrived. In April 2019, it detected something extraordinary, the first confirmed Marsquake. The vibrations were faint, subtle, but unmistakable. For the first time, humanity had heard the seismic pulse of another planet. What makes this instrument remarkable is its sensitivity. Even with its protective shield, it can pick up the vibrations of Martian winds or the faint movements of InSight's robotic arm just a few meters away. Each quake or tremor offers scientists a chance to model how energy travels through the planet's interior, gradually revealing its unseen structure. Meanwhile, InSight has been doubling as a weather station. It has tracked daily fluctuations in temperature, pressure and wind speed. Even at the equator, daytime highs barely reach minus 25 degrees Celsius, while nights plunge below minus 100. The thin atmosphere less than 1%, the pressure of Earth's whips up winds of 60 kilometers per hour. Through InSight, Mars has become more than a red dot in the night sky. It has become a place with weather, climate and daily rhythms. So why does all of this matter? Each tremor, each pressure reading, each gust of wind adds a piece to the puzzle of Mars's past. By analysing seismic echoes, scientists can reconstruct the planet's inner layers, much like a doctor performing a scan. This helps reveal whether Mars still has an active mantle, whether its core is solid or liquid, and how it has cooled over billions of years. Understanding Mars in this way doesn't just tell us about one planet. It tells us about Earth too, and about the processes that shape rocky worlds across the universe. The quiet work of InSight, in other words, may be key to answering some of the biggest questions in planetary science. As of now, InSight remains healthy, continuing to gather data day after day. The mission's greatest challenge may not be the Martian soil, but the Martian dust. Too much settling on the solar panels could eventually limit its power supply. Yet for now, it continues sending back readings that enrich our understanding with every transmission. If the mole can one day resume its digging, the mission will gain another dimension: direct measurements of heat flow from the interior. Combined with seismic data, this could give us a 3D view of Mars's internal structure, a scientific treasure we've never had before. So while InSight might not grab headlines like flashy rovers or rockets, its work is no less profound. It listens in silence, patiently revealing the hidden heart of a distant world. So let's keep watching this mission together. What began as a lander quietly sitting on a dusty plain may in time tell us how Mars, and perhaps even Earth, came to be. If you've enjoyed this journey through the InSight mission, make sure to check out our other explorations of Mars here on Cosmic Compass. And of course, thank you for joining us today. Until next time, let's keep looking up.